We had a request to do the mechanism of an alcohol with thionyl chloride and pyridine. And I chose this molecule here because this is reminiscent of the synthesis of sucralose, but you didn't need to know that. There's a reason the stereo center is different than it was before. Now, how does this start? Well, the important thing to remember is sulfur with its 4 bonds to more electronegative stuff is very positive. And the oxygen lone pair attacks the sulfur. And we don't break off a chloride when we have a pi bond to break first. We break a pi bond. And I think I can save some time in this mechanism until the very end, have this be another R group, but I used R already, call it R prime. So you're going to have R prime attached to an O that still has an H and now has a bond to sulfur with an O minus and 2 Cl. Do not forget formal charge on an O that has 3 bonds and 1 lone pair is plus. Oxonium. And I don't know, what color arrows? Light pink. The 2 steps that follow are interchangeable. You can do the acid-base version first, which is the pyridine reacting with the H on the oxonium, or you can do the elimination first. If you do the elimination first, do the acid-base second. If you do the acid-base first, do the elimination second. I'm good either way. I'm going to do the elimination. You get your double bond to S back. And you got a Cl. You got an O. Still has an H and a plus. You still got your R prime. Now do the acid-base step. Pyridine grabs the H from the strong acid. Pyridine cannot grab an H from a weak acid. It can't. It's too weak. But it can grab an H from an oxonium. There we go. And you're going to get this. Now, to make things a little better for you, on the exam, I give you side products, and I forgot to here. So I'm going to put them on here after I finish copying the result here. And it's time to copy our R group in its fullest. So, yeah, you're going to hit the carbon attached to the R here. Okay. And I'm going to give you your side products. HN pyridinium. And the other side product, wow, SO2 gas. And the other side product is really not a side product, it's a counter ion. I guess it's a side product, chloride. And I need to bring all those over to the original. Trying. Don't want to grab too much. I think I did because I did the OR at the same time. I didn't get the S. It's a disaster. We'll fix it later. And there we go. I did get the S. There you go. Stray dots. Okay, that's going to help us. So clearly you have to generate a Cl minus. I'd like to remind you, oops, we made a Cl minus here, didn't we? It was blue. That's going to be the nucleophile to do a backside attack on this carbon. That's why the Cl ends up on top and not underneath. And see if we can follow the arrows around. Hit the carbon. Sigma becomes pi. Leaving group leaves. My goodness, doesn't this look a little like tautomerization? It does. When you have multiple arrows flowing away from each other, that just feels like tautomerization. And yeah, that finishes it, right? We made the pyridinium a long time ago. That was right here. So you could, if you're doing like bookkeeping here, that's going to go up here. And then this is going to give the other two, well, 3. It gives that. It gives that. And it gives the Cl minus right there. Groovy. I don't need any of these pink arrows at the end here. I'm just, you know, if you're trying to follow the logic, it might help. And there you have it. Nice mechanism there.